So what I'm showing right now is a copy of OmniPeak, which is, as Tim mentioned, it's actually, it comes from EtherPeak. So it really is still, it's an evolution of that product still from 20-something years ago. But certainly if you compared it to that far back, it's a revolution, maybe a revolution and several revolutions. We've come a long, long way with OmniPeak. Nowadays, it is not just software we're going to use to go to analyze somewhere. In pretty much every case I'm going to show you today, we're really using OmniPeak simply as a console into an appliance. So we've either captured packets from that appliance and we're analyzing with OmniPeak, or the data has been analyzed on the appliance itself, and we're just looking at the results in OmniPeak. But to get to an introduction of it, I have just opened a few packet files that I have to make things easier, and just to give you a quick tour through OmniPeak. So for a high-level kind of monitoring view of OmniPeak, we have a number of dashboards. You can see those over on the left-hand side. I'm in the Compass dashboard, which is one of our newest dashboards. Built-in Flash and very interactive. You can see we can show the top protocols, the top nodes, the top flows. We can also show VLANs, and wireless. We can show channels and the wireless a wireless LAN view. Compass is completely interactive, which is very nice. If I see an area of time that I'm interested in, I just need to come in and highlight that area of time, and then everything below that changes to reflect that period of time. So if I highlight a spike, you can see I've drilled in on that spike, so now I've drilled in on 3 seconds worth of time, and now I see the protocols that are relative to that time, the top nodes, everything else. If I want to zoom back out, and then take different approaches. If I want to see, for example, what does the traffic do to simply this node, I can click on that node and it'll show me the traffic for just that node. If I want to compare it against the total, I can come back and compare it against the total so I can see where it falls in. If I want to overlay things like see that particular traffic and TCP traffic, I can do that and I can see where they overlay. And by doing that very quickly, I see, well, that user was probably mostly on TCP because everything kind of overlays kind of one-to-one. But Compass can give you just that flow to go through them. This doesn't matter if you've analyzed it 1 gig or 10 gig. It's going to open up whatever size file, and you're going to be able to get this this kind of visualization. We can see not only throughput. We can break it down by packets or by latency or by response time. So we can also graph response time through here, and now we're looking at total response time, maybe kind of odd. But then we can go from a response time perspective and look at it from maybe particular protocols or particular users.
The drop down there, I saw one-way latency. What does that mean?
Right, and one-way latency is typically something we're only going to see when we're doing a real-time capture. So since I've opened a capture file, I'm not going to see the one-way latency. But one-way latency, we do the one-way latency analysis, again, based on packets. So we'll go out and we'll look at, a request and act back to us. That's the network latency, that delta round trip. And then one way, the way we handle one way is if we have multiple appliances, then we can measure at one end and then the other end, then we can do one-way latency.
Oh, I see. Assuming clock sync, you've got 2 captured.
Right, and our appliances can clock sync at nanosecond rates. So right.
Do you have a pulse per second interface or 1588, or how are you doing that?
The appliances do have. It depends on what the user wants, but the appliances do have that's 1588. I think it is, right? It's the IEEE, right? And that's typically one of them. But then these come actually from the network interface cards themselves. It's not something that we implement, but I know they do the 1588. I'm not sure if they have any other techniques. I do. The one other technique they have is GPS, but not everyone uses the GPS time, and some people use GPS just because it's more convenient rather than the
timestamp comes from a dedicated capture NIC?
That's where, the 1588 is coming from the capture NIC itself. That's where the 1588 capability is.
Is that your NIC, or is that an off-the-shelf product?
It's not our NIC. It's we actually have a partner. Napatech is our partner.
Gotcha.
For the NIC cards. And that's 1 gig and 10 gig. But we have other partners as well. But the capability I'm talking about with the syncing is basically what we have with the Napatech card.
Cool, thank you.
And then for things like wireless, we have signal strength, which it doesn't really show up here. So just a general view of Compass in terms of the way you can go look at things. So in terms of actually capturing the data, we actually do that by connecting, back to any of these appliances. So that bar on the left-hand side has changed now. Instead of functions, these are actually different appliances that are running back in Walnut Creek. So I really could be anywhere in the world to go look at these appliances. Again, those happen to be running in Walnut Creek. I think the response time will be good. I just happen to be on a wireless network, not the hotel one, and because I was warned about that. I think I'm on Xfinity from across the street, I think, and I do have a VPN connection back into the office so that I can actually make connections back into these appliances. But the appliance I'm connected to right now is this one right here called the Timeline 32. So it's our network recording device that stays up at 12 gigabits per second. It's got 32 terabytes of storage in it, and we can see we're probably running tests against it, which these are usually typically in the QA lab. So we're steady state here. Probably average at about 3 gigabits per second, and the way similar to Compass. Which we look at for kind of smaller packet files. When we're looking at it, the appliance for 10 gig, we have similar traces in terms of what we can look at, network latency, or we can break it down by VLAN MPLS. We can break it down by protocols. We also have a call quality view, so we can actually see a voice over IP activity as well. And this is kind of interesting. I should kind of take a step back here. So again, this is a box that's capable of capturing packets up to 12 gigabits per second and streaming those packets to disk. Typically to do that, you really can't do a lot of analysis in there. But what we're doing is we're doing enough analysis to be able to display all of the things I showed you, the throughput, back on the other one, the top talkers. Let's go back here for a second.
Now, can the tool decode voice?
Oh, absolutely. Yeah. And I can show you that here in a minute.
More than just G711. Can it, like some of the compressed codecs that are licensed?
Yeah. So Avaya and Cisco Skinny, and we've licensed Avaya, so that's all in there. Megaco, and there's any others we can develop. They're over time.
And then like G729, 722. Like all the other
G729, G722, yep, we do both of those as well. Yep.
RT audio or?
RT audio, I'd have to actually even look that up, I'm not sure.
That's the Microsoft link.
Not natively today. I mean, but if it's standard SIP, then we're okay. If it's not standard SIP, then we would need to do something to handle that. So, in real time though, still at that 12 gigabits per second, we're identifying top talkers, identifying top protocols, getting the throughput graph in here, in addition to doing analysis like the voice. So, to get to the level of detail we were talking about here, where we actually get down to the, a decode, a breakdown of each call. I can show you that in a minute. We don't do that from here yet. This is just going to give us a graph of overall here number of calls that are going on, and then break them down by good, fair, poor, bad, based on mean opinion score. So we're able to do that. The way somebody interacts with Timeline to get to more detailed analysis is we would simply come into the area, this area, and maybe scroll across, and then from there we would decide we want to do a forensic search. So by doing a forensic search, it'll bring up a dialog box and say, what do I want to analyze in here? Is it just based on that time frame? Do I want to apply some extra filters or whatever? And then by going and doing that, it would actually go and direct the appliance to analyze that specific set of packets. We don't bring the packets back over the network at this point. The appliance, the distributed appliance, still analyzes the packets. I don't know how much time I selected, so there's a fair bit of time here. I'm going to take a relatively small slice. And it might take a second, so we'll wait for that to happen.
When you started developing this application, did you find that your features, you had a set feature set in mind that you wanted to capture, and this grew organically, or did you go, this is our roadmap, this is what we want, and this is where we want to get to? Well, it seems to be very, very detailed.
Well, I mean, we certainly have a roadmap to those things that we want to get to. But the nice, in some ways, the nice thing for us is if it's IP, it's available to us because it's there in the packet. So as new technologies come, we certainly add those to the roadmap. I mean, voice was one, right, and then video. Video started to become more popular. We have some video analysis as well. But it's only really as things get added into the IP stacks and become popular protocols that we then add them to the roadmap.
And what do you find the hardest thing to achieve with your application if you're looking at capturing some of the things that have been tricky for you?
Well, certainly the high-speed stuff has been tricky, right? Just finding a way to balance how much real-time analysis versus just getting a storage, getting the packets somewhere where you can then come back and do more detailed analysis later on. That's always still a little bit of a struggle, right? And the networks are getting faster. We're going to 40 gig. We're going to 100 gig. Number one, there'll be very little real-time analysis. We'll be able to store them all. People will be able to come back in time. But even with the coming back and analyzing certain segments, analyzing them on the same machines that are trying to store the packets becomes a challenge because so much of the machine power is being taken just to write the packets, right? So that's certainly one of the tricky areas. And the other area is, mentioning the Microsoft VoIP, is in areas like VoIP and others where people take, what's there, but then start building proprietary protocols around that. That's a little bit difficult sometimes. If the specs are open for it, it's a lot easier. If the specs aren't open, we'll get requests from customers, right, can you do this protocol for us? And, certainly we can, but our request back is often, do you have a spec, or do you have packets, or do you have something you can give us? Because, if we don't know what the protocol is, we're a little stuck.
Cool, thank you.
Yeah. So those packets came back, and you can see, and then we wind up in kind of more of the detail of what we can see with OmniPeak. So now those were voice and video packets. So in terms of our voice and video analysis, we're able to see in a more detailed dashboard, what those calls look like, and even more specifically, we can bring up our calls view, and just reset that. So in our calls view, we'll actually show a list of each and every one of the calls that was on the network. And then in the media view, we break those calls down by the different directions, so from the caller to the callee, etc. And we can highlight one of those legs, and in there we see the detail of that call. The mean opinion scores for that call, down, probably low, sorry for you guys. Mean opinion score down in here for that call, right? Listening quality, call quality, predictive quality, the R factor, everything else about the call, one-way delay, packet loss, jitter, all these features for that call. And typically, I'm not sure what this call looks like, but...
Can you see that on each leg of the call?
You can. So here I highlighted, this leg right here, right? But this is call 2. There's obviously a number of legs in this call, so I could highlight any one of those and see it for each leg, right?
Another question, if I could. Actually, relaying a question somebody just asked through IRC. Can, like the timeline device, can that store to like a SAN, for instance, or are all your appliances local storage only?
Today, everything is well, we can go to SAN storage. There's a different card we would put in the appliance, and then it can write to SAN storage as well.
Okay.
But in most cases, people buy just a self-contained appliance, but it can go to SAN.
Thanks.
I'm curious, does anybody, I mean, you're talking about Moz scores here, which is great, but is it used, do you see it used very often outside of a troubleshooting context? So maybe, like monthly reporting, somebody goes in, is there some sort of a way that you could give those kind of statistics to like a call center person who doesn't really know networking? Right,
a little later on I'm going to show you, we have one other product that takes information from our packet-based appliances and rolls them up kind of to an aggregated database and stores data minute by minute, and we actually store all of our closed calls there, and then from there you can generate more of the standard call detail reports that just kind of have the Moz score in there that somebody could generate and send off. So,
sweet.
Yeah, I'll show you that a little toward the end. So that's, that's I mean, kind of the way we interact with our different appliances. You can see there was a number of different appliances back there, but that's pretty common. Now that's with our timeline appliance. We do also have some non-timeline appliances that are running back in Walnut Creek. These are appliances that could be doing analysis in real time. So, similar to what we would see if we just open a packet file, I can actually double click into that capture, into that data session, and this will take a few minutes because there's a whole bunch of packets there. And then, I can start to actually see the live capture from that particular appliance back there. So, in this case, we're not streaming the packets just to disk, we're also buffering the packets. So I can see the packets, and I won't turn on the scrolling because when you're doing it wireless and this far away, that's harder. But we can see a view of each of the packets. We can get into our expert analysis, where it's another very key part of our product, where we're able to break down all of this packet-based traffic we're seeing categorize it in different ways. In this case, we categorize it by application. And you can even see, right, WildPackets Omni, we can see basically our own session here, right, where we're actually connecting with OmniPeak to the data. We can see with all the traffic. You can see things are kind of changing in here. Some of the dots are kind of grayed out. Some of them are dark green. Dark green means we've seen traffic there in the last 5 seconds, and then in the areas where they're grayed out, we haven't seen them in the last 5 seconds. Anything where there's the other dot indicates that we have some additional analysis there, some expert events. Let's actually do the Omni one.
What is the architecture for multiple nodes in terms of, 4 appliances are deployed, all gets sent to a central database? Is there a separate appliance that you're in now in terms of coupling the UI from each appliance?
It's a good question. So the way OmniPeak and appliances interact is I can use OmniPeak to connect to any one of the appliances, kind of as I did here. They're all here, and I could have an active connection open to any one or all of them. But then I see the data back from one appliance at a time. So what a lot of guys do in Knox is there's multiple screens, and they'll have OmniPeak running, and you see there's all these tabs on the top, right? So we'll have one tab on one tab on another machine, so they can see each one at the same time, but they're seeing each one individually.
So is there a way to correlate or take out duplicate packets if the same appliance is sort of seeing the same packet?
Yeah, there is, and there's also one other thing that we do. So we have an additional product called WatchPoint, which I was going to show a little bit later, that will then aggregate the data from those 5 appliances, let's say, into a single database. So that doesn't deal with it at the packet level, but at the statistics level. So then you can deal with statistics, and then WatchPoint will still know which appliance to go to if you want to do detailed analysis if the packets are still there. But we also do have a way, even from within OmniPeak. Let me see if I did it earlier. Where'd it go? Maybe it's back here. We have a feature within OmniPeak that we call multi-segment analysis. And what multi-segment analysis allows you to do is if you have multiple appliances, you can actually track a flow across those multiple appliances without having to go open each one.
Right.
And this is something that I stored, but this is an example of one of those where we're tracking a flow from 172.20.203 all the way out to a 10.5 network. And in this view, we're showing you it's a delay type view, so you can see all the hops that it's gone through. If there's a number in the box like here, that means there's actually 2 hops in there, so we're missing a hop in there. We just don't have an appliance at that hop just to indicate that to somebody, and then we can see the overall delays through there. And then this same feature of multi-segment analysis also, you can look at it from a ladder diagram perspective, if that's of interest to you as a network engineer, so that you can see how the traffic is flowing back and forth and the flows. It's a little. Hang on, let me scroll over. The resolution here is a little. Oh, there was one in here. The resolution's a little bad. And then occasionally you'll see spots where there's even red dots that indicates where we've had packet retransmissions, so we can see those and those for users. So, and that's the multi-segment analysis is quite easy to be able to do from multiple, to look across the multiple appliances. So if I come back into Stage Eng and go into a flow.
What if you used a packet broker in the middle and then had spans going to that, and the spans were sending the same packet to the broker, and then this saw the same stream more than once? Would it realize that? And within some number of packets we can do packet deduplication, but there becomes a limit. I mean, if in time they're too far spread apart, we may not pick that up. But we can do packet deduplication if that's coming through in OmniPeak. But to get to that multi-segment analysis, you would actually do that from a flow. So right now, again, I'm connected to a particular box back in Walnut Creek. It's analyzing a bunch of traffic. I've isolated it down to, I want to look at the traffic back and forth between OmniPeak and an Omni engine. It's this server. That's actually where the appliance is running. That's the appliance's IP address. There's the user that's connected to it, and then once I do that, I can right-click, and there's multi-segment analysis. I would click there, and I'm not sure of the interconnectivity of all those, but it'll ask me about that flow, and then it knows these are all the engines that I'm connected to right now. I check them, and I say, yeah, go look on those engines to see if there's also that same flow is also on those other engines. Odds are here it's not, because these are all QA boxes, but yep, by doing that. So if you had one appliance that was out at a remote office, one appliance then back in the data center, one appliance at the connection to the WAN link, you would most likely see that flow in all three of those locations, especially if it was heading out to the internet.